Hi, so we are still talking about our topic right now, still about ratio, but this time a little bit different. This time we are going to talk about comparing ratio, and then I give a subtitle, not subtitle, the subtopic over here, ratio for any kind of condition, and this is the video part one. So this is the beginning, okay? So after this there will be the part two, okay? So please watch until the part two, okay? So let's start. Okay, so comparing ratio, what we are going to study in comparing ratio, the first we are going to talk about, of course, the concept of comparing ratio. The second, we are going to solve the really problem related to comparing ratio. And the third one, we are going to talk about combining two related ratio into one ratio. But the last one, the third one, we are going to talk this one in the second part. Okay, so the first part, we are going to talk about going to see in daily problem what is condition. Okay, so let's continue. Now we are going to talk about the concept of comparing ratio. So what is the concept of comparing ratio? Like I told you before, the subtopic of this one is a ratio for any kind of condition. It means a ratio for more than one condition. Wait, what do you mean ratio for more than one condition? We get a ratio from one condition, right? Yes, you are correct. But the ratio, we can use it not only in one condition. We can use it for the condition number one. We can use it for condition number two. We can use it for the third condition, the fourth one, the fifth one, and so on. Okay, so when we have a one ratio, okay, when we have one ratio and we can use that ratio in any kind of condition or more than one condition, we call it as comparing ratio. And since we have only one ratio for more than one condition, so we call this ratio as a fixed ratio. What is fixed ratio? Fixed ratio, it means the ratio must remain all the time same. Okay, so the ratio in the center over here, it must always the same. Why, sir? Why? Because we are using it into many conditions. Okay, that's the concept. Now let's see the real things in our daily life. Is there a ratio for more than one condition? Let's see. For example, Mr. Andy's iced tea is one of the best iced tea ever made. Have you ever tasted? Okay, Mr. Andy is mixing some tea and sugar to get 3 cups of iced tea. Each cup has different size. The amount of the tea and sugar is just like shown below. So this is the table of the amount of tea and amount of sugar in each cup. We have cup A, cup B, cup C. Amount of the sugar in gram, okay, and also the sugar in gram. Okay, the tea is 180, sugar is 60, tea 270, sugar 90, tea 360, and sugar 120. This is in each cup. Okay, so we are going to study the amount of the tea and sugar in each cup. What we can say about the secret recipe of this best iced tea ever made. Okay, let's see what we can find. Okay, I want to see the ratio. I want to compare. I want to compare the amount of tea and amount of sugar in each cup. Okay, what would I find when we compare, when we make the ratio? Okay, the amount of tea to the amount of sugar. Let's see. In cup A, the ratio. Okay, this is the cup A. We can call it as condition number one. This is cup B, we can say as condition number 2, and this is cup C, we can say it as condition number 3. Okay, in condition number 1, what we can find about the ratio? Of course, 180 to 60, and we can simplify this one. We divide 180 by 60, this one also divide by 60, so we get 3 to 1. In condition number 2, the same one, we got 270 to 90, and we can simplify this also. Okay, each of this amount we divide by 90, so we got 3 to 1. The last one is the same. Okay, the ratio in cup tea between the tea and the sugar is 360 to 120. Okay, and then we can simplify each of this amount. We divide by 120, so we get 3 to 1. Okay, so what we can say about the amount of tea and amount of sugar in each cup in each condition? Okay, yes, see, as you can see, the ratio is always the same, 3 to 1. Okay, this is what we call as comparing ratio. This is what we call as fixed ratio. One ratio for more than one condition. The 3 to 1, we apply it in condition number 1, in condition number 2, in condition number 3. Okay, one ratio more than one condition. Okay, the ratio of the amount of tea used to the amount of sugar used is the same for each cup size. The ratio is always 3 to 1. That's the point. Okay, so but the question right now, how about if someone use or change the ratio? When we change the ratio, of course the amount of tea or the amount of sugar will be different, right? So what would happen? What do you think? Yes, if we change, let's say we make the 1 over here become greater, let's say 3 to 4, what will happen? Yes, it will be maybe too sweet for the iced tea, right? Or maybe if we increase the amount of the tea, so this one is not 3 anymore, but this one is, let's say, 4 or 5 to 1, what will happen? The taste must be not balanced anymore, right? It will be bitter than before, right? So that's what will happen if we change the ratio. When we change the ratio of this condition, later the condition in each cup, the taste will be different. We will get the different result. We will get the different taste. So it's not original, again, belongs to Mr. Andy's recipe. Clear? Get it? Okay. So is there another example in our daily life? Of course, yes. There are a lot of examples in our daily life. For example, when we are going to bake some cake, maybe, okay, the ratio between the flour and then the eggs, the amount of the eggs, okay, and so on, so many. Okay, this is one of another example. I told you before, okay, about dough. Okay, have you ever made it? Dough. Okay, to make one portion of dough, Susie mixes 5 cups of flour with every 3 cups of water. Okay, the first problem is find the ratio. We are going to find the ratio of the amount of the flour to the amount of water used to make one portion of dough. Okay, this one is simple things. Okay, flour to the water. So our ratio is 5 to 3. Okay, can we simplify this one? This one already simple. So 5 to 3. Okay, second one. So you want to make 5 portions of the dough, the same dough. Okay, the similar one, not the similar, the same one. How many cups of flour and how many cups of water does she need? Okay, so since for one dough we use 5 cups of the flour and then 5 cups of the water, so when we are going to make 5 portions, just multiply by 5. So 5 times 5, 25, and 5 times 3 is equal to 15. So Susie needs 25 cups of flour and 5 cups of water. Okay, the point, the real problem is in question C. Let's see what is in question C. She uses 21 cups of water to make the same type. Remember, the same type. How many cups of flour does she need? We are going to make the same type. So because we are going to make the same type, we need to keep the ratio. We cannot change the ratio between the amount of the flour and then the amount of the water. Why? Because if we change the ratio, later maybe it will be too hard or maybe too soft, okay, with the dough. Okay, understood? And then we are going to solve this one in 3 methods. The first one is fraction, second bar models, and the last one without bar models. Okay, let's see. The first method, using fraction. As you know, ratio could be written in fraction. We are comparing the amount of the flour to the amount of the water. So the flour become our numerator 5 and the water become the denominator is 3. This is our first ratio, 5 to 3. The fraction 5 over 3. Remember, fraction do not write into mixed number, okay, when we talk about ratio. Okay, and then the condition number 2, this is the first condition. The first condition is 5 to 3. This is the ratio, the first ratio. And the second condition, what is the second condition we have? The water is 21 cups. So our denominator right here is not 3 anymore, but become 21. And as you know, from 3 to 21, we are multiplying by 7. Because we are going to keep the ratio, because we are going to keep the taste, the quality of the dough. So if the denominator multiply by 7, so numerator also multiply by 7. So we get the second ratio, or the second amount is 35 over 21. So she needs 35 cups of the flour. Get it? Okay, this is method 1, fraction. How about if we are using method 2, bar models? From the ratio 5 to 3, we can write it. We can make the bar models, right? We are talking about the amount. So the label is about the amount of the flour and then the amount of the water. Since flour is 5, so we are having 5 units here. And for the water, since this is 3, the ratio is 3, so the water is 3 units. Okay? This is the first condition. Our bar model is the first condition, is the fixed ratio. And the second condition, the condition is 21 cups of the water. So right now, this is not 3 anymore. How many over here? This is right now is 21. Okay, can you see it? And what we can write from these bar models? The bar model asking about the amount of the flour that we need, right? So this is our question mark. From this bar model, please pay attention to the water over here. The water 3 units. The water 21 cups. So we can write 3 units is equal to 21. Okay, our goal, remember, our goal is finding 5 units. Before we are calculating 5 units from 3 units, we calculate first 1 unit. 1 unit equal to 21 divided by 3. Why divided by 3? Because 21 is equal to 3 units. So to find 1 unit, 21 divided by 3 equal to 7. We get 1 unit. Remember, our goal is 5 units. So since we are already over here 1 unit, so let's calculate for 5 units. 1 unit is 7, so 5 units is 5 times 7. 35 cups. See? We got the same answer. Yes, 35 cups of food. Okay, this is method 1, this is method 2. Let's talk about method 3. Method 3 actually, it's still, the base is still the bar models. But this time, we remove the bar models. We don't use the bar models anymore. Okay, why? Because, yeah, if we could use something faster, we do it faster, right? Okay, from these bar models, okay, we don't draw the bar model for the third method. We just write the number of the units. Okay, as you know, these bar models come from the ratio 5 to 3. So when we talk about the ratio 5 to 3, we can think directly about the number of the units. So flour is having 5 units, water is 3 units. This one come from our ratio. One more time, this one come from our ratio. So when we talk about ratio, we can think directly about the number of the units without drawing the bar models. And as you know, water is 21 cups. Water is 3 units. So we can write 3 units is equal to 21. Finding 1 unit, just like before, 21 divided by 3 is equal to 7, and then our goal 5 units. So 5 times 7 equal to 35. So still the same one. She needs 35 cups of flour. So which method is the best one? It's all up to you. You can use the fraction, you can use the bar models, or without bar models. It's all up to you. Which one that you are a favorite one? Okay. Now, keep in your mind first, comparing ratio. It is when we compare, talking about comparing ratio, we are talking about fixed ratio. Fixed ratio, it always remain the same. So only one ratio. Okay. But this ratio, we can use it for more than one condition. And second, see, fixed ratio is always the same. Don't forget about it. Always the same for more than one condition. And To solve this one, if we are having a problem about fixed ratio, about comparing ratio, at least there are three methods that we can use. First one is fraction, second one is bar models, the third one is without bar models. Which one that you want to use, up to you. Okay. Okay, thank you for watching this video, and then we are going to study again in part number 2, still about comparing ratio. Okay, see you. Bye.